G-suits or anti-G suits are protective garments worn by pilots and astronauts to counteract the effects of high acceleration forces, or G-forces, on the body. These suits work by applying counterpressure to the lower body, preventing blood from pooling in the extremities and ensuring adequate blood flow to the brain, thus preventing G-LOC, which stands for G-induced loss of consciousness. Types of G-suits include air-based and liquid-filled designs. Air-based G-suits are the most common type, featuring inflatable bladders that are typically located in the legs and abdomen. These bladders are connected to a pneumatic system that inflates them in response to G-forces, applying pressure to the body. On the other hand, some advanced G-suits utilize liquid-filled bladders instead of air. These are often found in more modern aircraft and, well, can offer a more even and responsive pressure distribution. Full coverage G-suits, like the one used in the F-35, offer full body coverage, including the abdomen, legs, and even the chest area, providing enhanced protection against high G-forces. Re-entry anti-G suits, or REAGs, are used by astronauts during re-entry into Earth's atmosphere. They're similar to aviator G-suits, but are designed to counteract the effects of microgravity on the cardiovascular system. So, how do G-suits actually work? First, during high G-force maneuvers, inertia can cause blood to pool in the lower body, reducing blood flow to the brain. Then, the G-suit's bladders inflate, applying pressure to the abdomen and legs. This helps to prevent blood from pooling and, forces it back towards the heart and brain. This pressure helps to maintain blood pressure in the brain, preventing grey-out tunnel vision and ultimately, G-LOC. Pilots also employ G-straining maneuvers, which involve tensing muscles and breathing shallowly to further aid in pushing blood back to the core and brain. G-suits are essential for fighter pilots in high-performance aircraft, allowing them to withstand the extreme G-forces encountered during combat maneuvers and high-speed flight. Astronauts use G-suits during re-entry and landing to counteract the effects of cardiovascular deconditioning caused by prolonged exposure to microgravity. In some high-speed aerial racing events, pilots may wear G-suits to enhance their performance and safety during the demanding maneuvers. The G-suits, which is actually short for gravitational suits, are specialized garments designed to help the human body cope with the extreme forces experienced during high-acceleration maneuvers. These are the kinds of forces that fighter pilots and astronauts might encounter. So here's a breakdown of what they are, what they're used for, and how they actually work. First, what exactly are they? G-suits are tight-fitting suits that cover the lower body, often the legs, abdomen, and sometimes even the arms. They're made with multiple inflatable bladders and compartments that can constrict when needed. The design is lightweight and ergonomic, so pilots can move freely while still being protected against those intense G-forces. Now, as for their uses, the primary function of a G-suit is to prevent a condition known as G-induced loss of consciousness, or G-LOC for short. High G-forces can cause blood to pool in the lower parts of the body, which in turn reduces blood flow to the brain. By counteracting this blood pooling, the suit helps maintain consciousness and operational effectiveness during rapid accelerations and sharp turns. So it's a pretty crucial bit of kit for pilots facing those kinds of extreme conditions. So, G-suits are not limited to military applications. Astronauts also use them during launch and re-entry, and high-performance aerobatic pilots rely on them for safety during extreme maneuvers. They allow pilots to sustain higher G-forces for longer periods, which can be, absolutely critical in combat or when executing complex aerial maneuvers. Under high G-force conditions, sensors and pressure triggers activate a system that pumps air into the suit's bladders. As the bladders inflate, they apply pressure to the legs and abdomen. This pressure effectively squeezes the blood vessels in the lower body. The squeezing action helps push the blood back towards the upper body and brain, mitigating the risk of blood pooling, which can lead to blackout. When the G-forces decrease, the system deflates the bladders, allowing the suit to return to its normal, unstressed state. The effectiveness of this system really depends on proper calibration, so that inflation is both timely and sufficient to oppose the gravity-induced blood shift. In summary, G-suits are critical safety devices in high-speed aerial and space operations. By applying pressure to the lower body, they help maintain adequate blood flow to the brain during maneuvers that would otherwise risk causing blackouts, thereby safeguarding the pilot's performance and overall mission safety.